is y equals x minus 7 times x minus 2 times x minus 9. When I say find the zeros, that's the solutions. What are the values of x that make this equation true? Okay. Now, instead of y, we would have a 0 to make it true. But they're already in factored form, so we don't have to do too much work. So what we're doing is, when you'll have a function, you'll have y equals. What we want to do is find out what the value of x is that makes this equation equal to 0. So the first thing we're going to do is we're just, instead of the y, we're going to put a 0 in. Now when we start doing these, you'll get the habit of what you're doing and you won't necessarily have to rewrite this step. But what I'm showing you is when we talk about our zeros, those are the x-intercepts. That's when y equals 0. So we're just plugging that into our equation. And then what I have to do, first of all, make sure it's completely factored. Well, I've got x minus 7 times x plus 2 times x minus 9, which is completely factored. And then what I do is I just take and I set each one of these equal to 0, just like we did with the graphing, and we solve for x. So the first one we get x equals 7. The second one we get x equals negative 2. And the third one we get x equals 9. So my three zeros are 7, negative 2, and 9. And you can just write them in a list, 7, comma, negative 2, comma, 9. You don't have to put the x equals. You can if you want to. But when we take our quiz and it asks you to find the zeros, I'm just looking for the list of what values made each parenthesis turn to 0. Okay? Not hard because it's already factored. I don't have to do a whole lot of work. Everybody okay with that? Now on number 2, we've got y equals x to the third times 2x minus 4 times x plus 7. We still want to start the same way. We want to take y out and put 0 in. And then we want to set each factor equal to 0. And this one is a slightly different because what does this one have that the first one didn't have? It's got an x cubed. It's got an exponent. Well, what does x cubed mean? It means x times x times x, right? So whenever you have exponents, okay, that tells you how many times that one is going to occur. So we're going to start, and I'm just going to set it equal to 0 3 times because that gives me x cubed. Then we'll set the 2x minus 4 equal to 0. And we'll set the x plus 7 equal to 0. Again, I'm doing the x 3 times because x cubed is essentially x times x times x. And we're going to repeat the process. We're just going to solve each one of these little equations for x. Do you notice how we get 0? How many times? 3 times. So you can either write 0, comma 0, comma 0, or another way we write it is we talk about the multiplicity. The multiplicity is how many times that 0 occurs. So let me go ahead and finish solving these, and I'll tell you the 2 different ways that we can write the answers. So that's going to be 2x equals 4. So that's x equals 2. Then we subtract our 7 over here. So one of 2 ways I can do this. I can either write the 0 3 times, and then comma the 2 and comma the negative 7. That is one way. Or I can write it as 0, and then behind it in parentheses, put a multiplicity of however many times that answer occurs. How many times did we get 0? 3. So I say a multiplicity, and I'm not going to make you spell that word. Just you can put mult, okay? Multiplicity of 3, and then a comma with a 2 and a comma with a negative 7. Either way is okay. You can get 0 and write it 3 times, which is how many times we got the solution because of that exponent of 3. Or you can write 0 and then in parentheses you can put a multiplicity of 3 behind it. That tells me that you know that that is the solution 3 different times. So you could write your answer either one of those ways. Everybody okay with that one? So anytime your factored pieces have exponents on them, that tells you how many times that answer occurs. So I want you to try. All right, so we're going to, again, replace y with 0 so that we can set each factor equal to 0 and solve. How many times does that x plus 3 occur? 3 times. Now, do I really need to write it 3 times, or can I just solve it once and then put that answer 3 times? Okay, just do it once and then put the answer 3 times. I mean, that seems like that would be the easiest thing to do. So when I write my answer, it's -3. I can either write that -3 3 times, or I can put in parentheses a multiplicity of 3 behind it. And then I'm going to take that x minus 4 and set it equal to 0 as well. And my other solution is 4. Anybody have any questions? What did I forget? Or again, you could just write it -3 3 times, and then the 4 as well. And the order of your answers when you write your zeros doesn't matter, just as long as you have all the zeros. That's all that I'm looking for. Is everybody okay with that? Not terribly difficult, right? Okay, so now what we're going to do is I'm going to give you the zeros, and we're going to come up with an equation in standard form, which means basically we're working backwards from factoring and solving. Okay, so the directions say write a polynomial equation in standard form with the given zeros. And we're just essentially working backwards with these. Oh, excuse me. Bless you. Okay, we're writing a polynomial equation in standard form with the given zeros. And it tells me that x is equal to -1 and 3. And there's a comma behind it, but there shouldn't be because there's not another 0. There's just a typo. So here's the first thing we want to do, is we want to take each one of those zeros and we want to set them equal to x individually. Now I have two separate equations. I have one that says x equals -1, and I have one that says x equals +3. What I want to do is turn both of those equations equal to 0. How would I move that -1 over with the x? Add it. So we're going to add this -1 over here. So I get x plus 1 equals 0. And then I'm going to do the same thing with the 3. I'm going to subtract it over. And that gives me x minus 3 equals 0. So far, so good. Now I have two binomials. Both of those binomials are equal to 0. So what I'm going to do is I'm going to put each binomial in parentheses next to each other. And I'm setting it equal to 0. And then how do you think I turn that into an equation in standard form? Just FOIL it. Just multiply it out, okay? So what you need to do now is take a minute and multiply x plus 1 times x minus 3, combining your like terms. So we are just going to distribute, excuse me, x times x is x squared. It's -3x. That's positive 1x. That's minus 3. And we just want to combine our like terms, and we also we need an equation because that's in the directions. We have to have an equation. So we can either, I'll take two ways. You can either leave it equal to 0, or instead of equals to 0, you could put a y equals in front of it. I don't care which way you do it as long as there's an equal sign. And I'm going to combine my terms. That -3x and plus 1x is going to give me a -2x minus 3. That is a polynomial equation. Again, you could also, instead of writing it like that, you could write it as y equals, and then do the x squared minus 2x minus 3. Because remember when we were finding our zeros, we took the y out and put a 0 in. I don't care which way you write it, as long as there's an equal sign and it's an equation. Does that make a little bit of sense? All right, go ahead and try 5 then. Bless you. We are starting by setting each one equal to x. We're going to work backwards to turn them into binomials, getting them equal to 0. Then we're going to take each binomial and we're going to put it in parentheses next to each other. Then we're going to FOIL it out. I'm going to combine my like terms. And again, you can leave it equal to 0 or you can put it a y equals in front. It doesn't matter to me. I will accept either one. Anybody have any questions on that one? It's not hard stuff. Done it before. All right, let's take a look at 6. And this one's not hard either. It's just sometimes when we throw zeros in our as a 0, we kind of get confused when we start working backwards. So the first thing we do is the same as before. Set each one of my zeros equal to 0. This time, how many zeros do I have? Oh, okay. How many solutions do I have? Let me say that. 3. There's one numerical 0, but there are 3 answers, right? 3 things that x is equal to. All right, ouch. Let me show you something before we go on with this. If I look back at the first 2 that we did, how many x values did we have for each one of these? You had 2, right? What was your highest degree in your answer? A 2, right? The highest exponent tells you how many solutions you have. Not that that makes a huge difference, but sometimes we get confused with our multiplying things out. And that's just another thing that we can use to check ourselves. If number 6, I have 3 solutions. So when I multiply this out, my highest degree should be an x to the 3rd. Okay, it's just another way to kind of check and make sure you're on the right track. So again, we're going to set x equal to 0. We're going to set x equal to 7. And we're going to set x equal to -4. Does it do me any good with the x equals 0 to either add or subtract 0 over? No, okay, because it's going to still be just x. So I'm going to leave that one alone for now. I'm going to subtract my 7 over, so that's going to give me x minus 7. I'm going to add my 4 over, which gives me x plus 4. Okay, I'm skipping a step. Is that okay with everybody? Now I have 3 solutions that I have to put next to each other to multiply. That single x, I'm just going to put in the front. And then I'm going to put my x minus 7 in parentheses, and I'm going to put my x plus 4 in parentheses behind that. When you have a variable in the front and you have a couple of binomials behind it, what I would recommend is let's multiply our binomials together first. Let's leave that x alone for a few minutes. Let's go ahead and distribute. And then once I distribute the 2 binomials, then I can take whatever is in the front of those and distribute it. Or you can combine your like terms first, either way, but I'm going to go ahead and distribute. And then I'm going to combine my like terms last because I distributed first. Either one of those steps can be rearranged. And my polynomial equation is x to the 3rd minus 3x squared minus 28x equals 0. Or you could put y equals in front of it. Is that one okay? All right. I want you to try 7. I'm going to give you a few minutes to do it, but let me ask you this. How many zeros, like numerical value zeros, do I have in this? Okay, I have 4 solutions. How many the number zeros do I have? I have 2, okay? So with the first one, we only had 1 0 as a solution, and we put that x in the front. So this time we have 2 zeros, so what do you think should be in the front? X squared, okay. Yep, go ahead and try that. Now, for 7, the one thing I would say is whenever I have the number 0 as a solution, I would put however many of them I have, put that first, okay, and then just put an exponent that tells you how many of them there are. Then I can do my Sorry, I was skipping a couple steps there. Then I can do my other two numbers. It doesn't matter the order of those. That's going to give me x plus 3. That's going to give me x minus 5. Again, I'm going to hold on to that x squared for a few minutes. I'm going to go ahead and distribute out my binomials. And then I'm going to distribute the x squared. And then I can just combine my like terms. So that's going to be x to the 4th minus 2x to the 3rd minus 15x squared. And again, either put y equals in front of it or just equal 0 behind it. Just make sure you have an equation or equal sign. That makes it an equation. Is everybody okay with those? Okay, now I'm going to make it slightly harder, but it's still not very hard. Everybody ready? Okay. Let's talk about 8 first. We got negative 2/3 and 1/4. Okay, negative 2/3 and 1/4. Those are our two solutions. So again, we're going to do the first step exactly the same. We're going to set each one of those equal to x. This one, the working backwards, just involves another couple of steps. First question, do we ever write polynomial equations with fractions in them? No. So what we want to do first, before we start working on putting binomials and then multiplying everything out, is we want to take a look at each one of these. I have equations. I have x equals negative 2/3 and I have x equals 1/4. They both have fractions in them. Let's get rid of those fractions first. If that first one, if I have x equals negative 2/3, how do I get rid of the fraction? Multiply both sides. Whoa, that wasn't supposed to happen. Come on. Sorry. All right, so we're going to multiply both sides by the denominator. In this case is the 3, okay, just for this first one. When I multiply negative 2/3 by 3, those 3's cancel each other out, which gets rid of my fraction. So that gives me a 3x equals negative 2, right? Now we're going to keep working. How do I get this equal to 0? What do I do with that 2? I just add it over to the other side. And so that's what my binomial would look like for that first one. Is everybody okay with that? Well, how would I get rid of my fraction on the second one? Multiply both sides by 4. So this is going to give me a 4x equals, those 4 cancel, a 1. Then I can subtract my 1 over to get it into a binomial equal to 0. After that, it's exactly the same. Okay, we got rid of our fractions. So we now have two binomials that we're going to put in parentheses next to each other. And we're going to multiply out. The only difference is we have numbers in front of our x's now. Go ahead and continue to multiply. Combine your like terms. Make sure either put y equals in front of it or put it equal to 0 behind it. So completely multiplied out, terms combined. Did we all get 12x squared plus 5x minus 2 equals 0? All right, go ahead and try 9. Starting off exactly the same way we did last time, setting them both equal to x. I do want to get rid of my fraction before I try to turn it into a binomial, so I just multiply both sides by the denominator. Then I can move that other number over with the x. Same thing on both pieces. So did we all end up with the two binomials, 6x minus 5 and 3x minus 2? All right, so then we just put those in parentheses to FOIL them out to get our polynomial equation in standard form. So I got 18x squared, what, minus 27x plus 10? Everybody agree with that? Okay, I got one other type of problem to take a look at. Is everybody okay with number 9? We're going to throw in imaginary solutions. So we'll start with number 10, and these are actually not very hard as long as you remember one particular thing about your imaginary numbers, but we'll get there in just a minute. I have x equals 4i and x equals negative 4i. We start off exactly the same. Set each one of them equal to x. Then make them binomials equal to 0, just like we've done with every other problem. Just this one has an imaginary number in it. Process is still the same. I'm going to subtract that 4i over. So that gives me x minus 4i for that one. I'm going to add the 4i over here. The only difference is they have imaginaries in them. Everything else so far has been the same, right? All right, we have two binomials. Let's put those two binomials in parentheses. Now we're going to work on FOILing them out. Don't get confused because there's x's and i's. The process is exactly the same. We're going to distribute. That gives me x squared. When I multiply x times 4i, I just write it as 4ix. You could write it as 4xi. It doesn't matter as long as they have both of the letters in there. I'm going to multiply the negative 4i times the x, which is going to give me a negative 4ix. What do I get when I multiply negative 4i times positive 4i? I get a negative 16i squared. I'm going to stop there for just a second. So far, so good. All right, now we got to start working on combining our like terms and getting this thing in its simplest polynomial equation form. What happens to the positive 4ix and the negative 4ix? They cancel. Now, there's one thing we need to focus on. That's this last piece right here. Do we leave I squareds in our polynomial equations? No. Does anybody remember what I squareds equal to? Negative 1. So essentially, this is a negative 16 times a negative 1, right? Which turns it to what kind of 16? Positive. And that is my polynomial equation. If I have a negative 16i squared, that's negative 16 times negative 1, which gives me a positive 16. Think back to when we did complex numbers. Our I squareds always change the sign of whatever it was attached to, right? All right, quickly try number 11. This will be the last one. You got a 2i and a negative 2i, and it's going to be pretty much identical. I didn't put x equals in front of it. Yeah, x equals 2i and negative 2i. I just didn't write that down. Make sure, again, when you're writing equations, you should have an equal sign in your answer somewhere. It can either be y equals and then your answer, or your answer equals 0. They are both equal to x. I just forgot to put the x equals in front of them. Making my binomials. Putting my binomials in parentheses to multiply out. Distributing. My middle terms cancel. And again, what does this I squared make that -4 turn into? +4.